Welcome to EDU World Space.
All right, so we want to express this integral in 6 different ways. So first, let's look in the xy plane. So that's when z is equal to 0. So what are we left with? We got y is equal to x squared, and y is equal to 4. Right? If it's 0, this guy is 0.
Here's a clean and professionally formatted
Right, so
presentation
let's
of the
graph
calculations
this.
shown in the image.
The x, y plane.
Application of the work energy theorem, WET. From the
y
work
equals
energy
to
theorem,
4,
the force
like
F
that.
is given
So
by F equals frac
we're
times
dealing with
KE,
this
where
region right
KE
here.
equals kinetic energy, S equals stopping
Okay,
distance. I'm given
and
for object
one more thing
A,
I'm going to do here
FA
is I'm going to
equals frac
solve
100,000,
for z.
0.10.
So if I solve
For
for z,
object
I
B,
get 4
FB equals frac
minus y
225, 1500 equals
all over 2.
0.15 text space n.
So
And
first
force
thing,
ratio
let's
frac
do this as
FA,
region 1.
FB
So my x's
equals
are
frac
going to be
0.10,
ranging between 2 and
0.15
negative
equal frac
2.
2 null result. A box
The way
frac
my
FA,
y's are going to be
FB.
ranging,
Would you
just
like a
based on this
PDF version
picture,
of this explanation?
it's like so. And then my z, well, my lower bound for z is 0. And my upper bound is 4 minus y over 2. Okay. So let's write our integral. So since I've set z equal to 0, I'm integrating with respect to z first. And then over here, it looks like I'm integrating with respect to x last. So my x bounds are just numbers. My z bounds look like that. And then my y bounds look like that. Okay. Now, treating this region as region 2, got dz, dx, dy. So integrating with respect to x first. So we see that our y bounds are going from 0 to 4. Okay. So we know our y bounds are 0 to 4. These guys are still the same. But how is my x changing now? Okay. So if I look at x changing in terms of the region like this, well, it's pretty obvious that it's going to be changing like this. If y is equal to x squared, then plus or minus square root of y is equal to x. Okay. So now let's do the y z plane. So x is equal to 0. So if x is equal to 0, we've got y is equal to 0, z is equal to 0, and y plus 2z is equal to 4. Okay. So yeah, so let's do this. We can also solve. Yeah, so let's go ahead and draw this out. Got y, z plane. Z is equal to 0, y is equal to 0, and then we've got this line here, which is remember z is equal to 4 minus y over 2, or 2 minus y over 2. So we've got this region here. Okay. And when y is equal to 0, this is equal to 2, and when z is equal to 0, y is equal to 4. Okay. So treating it, we have to find our x bounds, and we also have to find, well, okay, if we want to find our x bounds, we just have to solve for x here. Right? So our x bounds are, again, square root of y minus square root of y. Then we've got our y bounds, and we've got our z bounds. So we have to figure out which order of integration we want to do. So if we do this way, our y bounds are going to go from 0 to 4, right? And our z bounds are going to go from 0 to whatever this line is, which is, of course, 2 minus y over 2. Okay. So integrating, fxyz. We want to do x, then let's do y, and then let's do z. So we know that, this is what I want. So we're doing y last, so let's switch this. We're doing y last. We know our y's are going from 0 to 4. We know x's are changing like this, and then we know our z's are changing like that. Okay, so then we want to switch the order of integration here. So our x's are still the same. And what are our y bounds? Our z bounds are from 0 to 2. So our z bounds are from 0 to 2. And our y bounds, well, they're just y equals 4 minus 2z. Let me just circle this. This guy I get from this guy here. All right, so almost done. We got 2 more integrals to do. So we looked at the xy plane, we looked at the yz plane. Now we need to look at the xz plane. So when y is equal to 0. So when that happens, we've got x is equal to 0. We've got z is equal to 0. And then we've got 2z is equal to 4. So z is equal to 2. Okay. So that's when y is equal to 0. All right, so let's draw this, what's going on. We've got x is equal to 0. Z and x are equal to 0. And we've got z is equal to 2. Okay, so looks a little weird. Just make sure I'm doing this right. Okay, so how else can we write this, right? Because this isn't really giving us anything bounded. Well, we know that y is equal to x, and we know y plus 2z is equal to 4. So we could also write x squared plus z is equal to 4. Okay. So let's figure this out, right? We need to integrate. We still need to do dy, dz, dx, and dy, dx, dz. Okay. So we know that our z bounds are from 0 to 2. Figure this out right here, right? 0 to 2. Okay. How are our y's changing? Well, we can just solve for both values of y, right? Like such. Okay. And how are our x values changing? Well, it's pretty clear that we have to, sorry, it's not 0, obviously. We have to solve this guy for x, right? So x is going to equal plus or minus square root of 4 minus 2z. Okay. Minus 4 minus 2z and plus 4 minus 2z. Okay. Now for this guy up here, still got x squared, still got 4 minus 2z. And now we need to figure out, well, how x and z are changing with respect to one another, right? So let me make a new. We've got, so what do we have? We got x squared plus 2z is equal to 4. So what does this mean? So z is equal to 2 minus x squared over 2, and z is also equal to 0. So there are our changing bounds for z with respect to x. 2 minus x squared over 2. And then, well, what happens when z is equal to 0? So we know that the upper bound for x is, well, we don't know. Well, let's plug in z equals 0. So if z is equal to 0, what do we get? We get x is equal to plus or minus 2. So there are bounds for x, -2 to 2.